Alrighty, well, this is exciting. We've got three amazing speakers coming up next, all from the Center for Wild Research. Obviously, this is an organization that's been around for a long time and really got the southern residents on the map, so to speak, as far as research is concerned. There's a lot that's happened already to date. All research associated with the southern residents ultimately has to use the center's data, and so we researchers and community are so thankful for the data set that has been accumulated over time. So there's going to be, I think Michael has an introduction, and then we're going to have Dave Ellifrit, just a mastermind for, he's the savant for photo ID, super excited to hear that one. And yeah, we've got an hour and a half or so of great talks, and hand it over to you, Michael.
Thanks, Giles. Good morning, everybody. Thanks for having us here. It's really good to be able to talk to you all and give you all a bit of an update about what we've been doing at the Center for Whale Research. So my name is Michael Weiss. I'm the research director at CWR. And the CWR really has three main pillars of what we do: research, conservation, and education. I think you've heard a bit about some of the conservation work we're trying to do with Big Salmon Ranch. If you're interested in the education side of what we do, we really encourage you to go down to the Outreach Center down by the ferry landing. Today, the three of us are going to give kind of an update on the research side of it, which is really kind of the base level of what everything we do. First, we'll have a little video from Ken explaining how the study kind of got started. I'll then hand over to Dave, who'll give an update on our long-term photo ID project, what's been going on the water, what we've been seeing both with the southern residents and also with the biggest killer whales. Darren will then talk a bit about the kind of academic side, the really kind of amazing theoretical breakthroughs we've been able to have by analyzing the southern resident data. And then I will come back and I'll tell you about some of the new research we've been doing, especially using drones to observe killer whale behavior. So with that, I will hand over, I guess, first to Ken.
My name is Ken Balcom. I'm the senior scientist at the Center for Whale Research in Friday Harbor, Washington, San Juan Island. I went to college in the late 50s, early 1960s, University of California. I majored in zoology. That was fascinating, the thing to do. What else you can do with your life? You know, what, be outside, study stuff? Cool. So I got fascinated with whales, and the first job I was offered was counting whales in Puget Sound. There was a myth going around that you can't tell them apart. It's like fish in the ocean. How are you going to tell this fish from that fish, you know? The U.S. government didn't believe at the time that the science was that good that you could tell whales apart, or the photography was that good. So they hired me to see whether or not it was. The fin and the saddle pattern on them are the identifying features. And the saddle is that gray pigment area just behind the fin on the back. It varies in shape. It's an area where scratches show up nicely, and that's how we tell them apart. Back over to this one. This is 36 years later with virtually identical photographs of the saddle pattern. The system works. It's wonderful. It's very, very handy. I began the study for the U.S. government under contract on April Fool's Day, 1976. By Halloween, 1976, we'd identified everybody there and concurred completely with Mike Bigg that we knew everybody, every whale in the population. We had 70 whales, all of them we could tell apart. They're the southern resident community in JK and L pod. So if we could do that in 1 year and then do it the next year and see all the same individuals and do it the following year, then we'd see who's the new baby. We'd have a population of animals that we would know completely over a life cycle. and answer questions that were biologically interesting. So off we went and did it. That was 1976, and I'm still doing it. When I got into cetology, the study of whales, actually it was in 1963. One of the attractions was that not many people knew much about them. For me, it was a perfect, uncrowded field to explore biology the way, you know, the people that I respected in history have done. You know, just follow an animal group and learn as much as you can about them and tell people.
Great. And now I'll hand it over to Dave to give an update on Orca Survey.
All right. Hi, everybody. I'm David Ellifrit. I've been working with the center for over 30 years now, and thanks for having us all. But as Ken said, Ken and his team continued to take identification photos over the years. They had funding in 76, had none in 77, got a little bit of money in 78, and then basically had to find money to take pictures for years after, and then starting in 87, Ken got funding through Earthwatch, and this is a photo, only photo I've ever wanted from the internet. But here recently, I was reading headlines and reading one of the many articles about the keel-eating whales of Gibraltar, and they used this photo. And I'm guessing somebody said, I need a photo of an orca with a sailboat, and they found this 30-year-old photo of us on high spirits with J3. I believe this photo must have been taken somewhere before somewhere between 92 and 94, because I'm reasonably certain I'm driving. J3 was dead by May of 95. And this is the era where Ken was grumpy about the price of boat slips in Snug Harbor. And we had high spirits on the mooring in front of the house. And every morning when we had our Earthwatch teams, we'd row them several trips out to the boat in the raft. And then often, especially if we left whales at East Point, it's a 3.5-hour boat ride home in this boat. And people would sleep in the raft on the way home. But anyway, I thought this was kind of a funny photo to bring up when, for all these sailboat-eating whales. Anyway, we did Earthwatch for 20 years, and then things changed in the early 2000s. The whales got listed. Earthwatch wasn't going to work very well anymore due to permits and regulations, and we started getting government permits to do our photo ID stuff. So we continued on, and basically the first 25 years or so were the black and white era, and then the early 2000s was age of digital, and we started getting trigger happier. Anyway, so we continue on taking photos every single year. And I believe we were at 73 whales, down to 73 whales last year, at the end of the year. Anyway, so we started 2023, brand new era, but we're still here, still taking photos. And yeah, so 2023, you know, as an update for the year, started out a little slow with us. Didn't really see much in January, but starting in February, we had at least one encounter with J-Pod every month. Most of our encounters over the winter with them, they were super spread out, and we could never find everybody any one day, but you put any two encounters together and you usually had everybody there. And J59 from last year is fat and looking good. Yeah, and so, like I said, the year kind of started out a little slow like they usually do. And then on March 18th, we got word that K's and L's were down in Monterey Bay. And the California Killer Whale Research Project, Nancy, Elisa, and Tomoko were all in direct contact with us from the very start and to let us know that those guys were down there, and they sent us photos, and we were able to, ID. It was kind of K's and L's, it wasn't all of L-Pod, it was kind of a group we unofficially refer to as the 19 L's, which is basically the Matrolines, the L4s, L47s, L72s, L90, and now L87's kind of hanging out with that group. So it kind of bounces around between 18 and 20 whales, depending on who comes or stays every year. But they got a picture of all of them, and K-Pod was apparently later in the day, and you could tell from the photos that the day was starting to deteriorate, and the whales are spread out, and they didn't get them all, but got about 3 of them. So that was March 18th. And then on April 8th, those same 19 L's showed up at J-Pod west of Victoria, heading back out. But our team member, Mark Mallison, who works out of Victoria for us under our Canadian permit in his own boat, got out on them. And that was April 8th. And that was pretty much the last we saw of any L-Pod whales for a couple months. But anyway, J-Pod was still kind of around. And then, we had our usual big killer whale starting to pick up come spring. And May is really our time to get out on them because we get bigger groups on them. And we've had, to date, the center between us on this side of the border and Mark out of Victoria, we've got photos of, we have documented over 110 different big killer whales this year, and I don't think we even got everybody who's come through. But anyway, they rolled through, and some of our favorites have rolled through. The T-87 is still kicking around. This guy is pretty much the last adult male that shows up in our area that's still older than I am. But he's probably 60, and he keeps going. And anyway, it's always good to see him. Some other favorites came through, T-63. And we actually had we try to go out on the bigger groups. It's just easier to deal with, and that way we don't have to spend as much time on the single groups that everybody's watching. But we had a group of 32 transients this year in Rosario Strait, and I've had that many in a day before down here, but you couldn't really call them the same group. But we had 32 of them rolling up Rosario Strait one day, and all social, acting like residents. Anyway, so anyway, we had our usual, well, I don't know, we got one stellar. This wasn't actually a kill, but it was made for a better picture than the actual kill later in the day did. But we got some whales looking mean, and some whales who aren't looking so mean. This is T49A6 with its little banged in nose, and it's very reminiscent of Charlie Chin of old, from back in the early, he was a star in the 70s, 80s, and very early 90s, but was well known for his protruding lower jaw. But that might have been a birth defect. But after looking at pictures of T49A6 from the first year, there's a little injury. He did not have, or it did not have that little bashed in face when it was born, so he must have hit the bottom of a rock or something. But anyway, it's made it a very popular little whale around here. Anyway, so so I believe it was, we had our transients through the spring and early summer and the occasional appearance of J-Pod. And then I believe on June 20, we were made aware of photos taken on June 21st of some L-Pod whales off Tofino. And there was a little calf with L119. And so that was exciting to us. we had made a plan because we didn't know if these whales are going to come in, because who knows what's going on this day and age. We made a plan to go out and spend a few days working out of Port Renfrew to see if we couldn't find the calf and anybody else out there. And wouldn't you know, after we committed to that plan, the L12s came in, or yeah, Jays came in kind of on the 25th of June and then left real quick, and then they came right back in on the 29th with the L12s. And then I think on 30th of June, we went up to the coal docks, and we knew they were ahead of us, and we couldn't find them there, and it was kind of crappy water to the north of us, but we went on a little whale surge, played around with some humpbacks for a while, took a pit stop over at Point Roberts, and came back out, and the whales were right where they were not just an hour and a half before. But we immediately found a couple of the L12s, so all right, confirmed the L12s were there, and fairly quickly found we found a calf, and it was like, all right, there it is, it's still alive, except it wasn't with L119, it was with L113, who's from a related but different matriline, and that was a little confusing. And the calf really wasn't coming up, and occasionally was in echelon position, but not always. It was bouncing around. It was kind of clear they were having a good time, and then L94 finally showed up, and then the calf slipped right into L94's side, and it's like, there's Mom. But it was a real good sign that L113 was so interested in the calf, because we're hoping she has one here at some point too. But anyway, so, all right, well, the thing is like, okay, well, this isn't, even the fin shape didn't look right for us for the photos that we were seeing of the calf off Tofino. So it's like, could it be a two calf day? And once we were satisfied with our photos of this calf, we went looking, and sure enough, found another calf with L119 and J-pod whales all around. So. So both calves looked really good. They were both filled out, fat. They're both in their peely stage, so they're probably over a few months old. But I don't know if you can tell it, but this is L126, and he, I guess, does have an open saddle on both sides. It's a little bit kind of K34-esque on the left, kind of J42-esque on the right. Anyway, we were feeling pretty good about getting the sex on these calves early, because the very first day he was being thrown around, and we just couldn't quite get it. And then the next day we went out, because they were down the west side, and we decided to call the Tofino whale L126 and the L94 calf L127. L127, the second day, was being tossed around by Mom all over the place, and we kind of got crappy pictures, and then a couple of days later we got better pictures, and then and Michael got stuff from the drone. But L127, L94's calf, is a little girl, which makes that little matriline an awesome little matriline with a whole lot of hope for the future. And we were pretty sure we were going to get L126 too, because he was also being thrown around, and sure enough, he was a little male. So anyway, it's I'm not sure people appreciate how many years, or how lucky we are to get these sort of stuff so early. I mean, there were so many years, decades, where these whales would start sprouting before you could say they were a male, or they had a calf before you could say they were a female. Something happened in the digital era. Where I think everybody got trigger happy, because you can just hold the trigger down, and you can get all the little, instead of trying to time it with black and white, you had to, count your frames. Somewhere, the moms started throwing their kids around, and we're getting all these sexes a whole lot earlier than we used to. We still had our trip out west planned, and we decided we better go out there, because who knows when the rest of the L's are coming in. And we have a kind of weird July 1st reporting date, which this day and age makes it really hard to get a number. on July 1st when we're not seeing the whales. So we decided to go out west, and I went over to Victoria, and Mark Mallison and I went out in his boat, Mike 1, and our team member, Joe Zoito, drove the truck out there to Port Renfrew, and we picked Joe up, and we did a little tour of Swisher Bank that first day. This was not the day because we got weathered out that day. But the water wasn't quite as nice as we wanted, but we had a few days. So the second day we went out, it wasn't quite the water we wanted, but if you creep up the shoreline up to Cowichan Point and Nittinat Lake, you can have a good ride down to where Swisher Bank is. And anyway, the second day we found L54 and L108 out there in the gloom all by themselves feeding. And we saw L54 get a salmon, right in front of us. And it was like, well, at least we saw somebody, but only seeing 2 of that group of 4 was a little, well, where's the rest of them? But the next day we went out and the weather was a little bit better, still not great. Went to where they usually see the whales on Swisher in September, and they weren't there. So we went to the southwest edge of it and dropped the hydrophone, took a little break, dropped the hydrophone, and we got our ears blasted out by Southern resident calls, and it's like, holy crap, where are they? They ought to be right here. It was just the loudest Southern residents I've heard on a random hydrophone drop ever. And then Joe went to pee off the stern of the boat, and he went, oh, here they are back here. Yeah, anyway, it was a good day, and we found JKs and Ls out there, and it was everybody. We fairly quickly found, we were kind of a little bit worried about L88 and L117. Saw them immediately, so it's like, all right, those 4 are there. And we basically saw everybody. The kids were out there. This is L126 with Grandma, L77. And there's L94 and L127 and J41. And they were, we saw last year's K45 is fat and seems to be doing well. Here she is with K33. Anyway, and both days, we had 2 days in a row, and both days we had big groups get together briefly, and there's a lot of social stuff, but they're also very spread out. And and there are like, and one thing that was really noticeable is finally all our sprouters are finally starting to sprout. I mean, everywhere you look, there is just big dorsal fins everywhere, and I think all our dead-end matrilines are going to become real apparent here soon, because all those moms with single sons the sons are starting to grow, and they're starting to be noticeable from a distance. And L108, L109 are getting big. L110's finally looking like a 15-year-old, and L115, even L116's sprouting. So they're just, all the boys are looking big out there. But anyway, it was a neat day. And then the last day, which was this water. Joe drove the truck home, and Mark and his dog Finn and we decided it was too nice of water not to do one little loop, and we went out and found the whales exactly where they were the day before, and just flat ass calm. I mean, you just don't get days like this out in the ocean very often. It was a little too bad that we weren't quite sure where our fuel gauge was, and we had a little bit of an iffy engine from the day before, and we still had to get to Victoria. So we had 65 miles to go before we got to Race Rocks that day. So we had to leave the whales a little bit early on that gorgeous day, but good thing we did, because the Strait of Juan de Fuca was not nice. But anyway, one of the neat things about working out there in somewhat sloppy waters, you get chin shots. Lots of chins, and all you can want. But anyway, that's kind of pretty much the story of how 2023 has gone so far. We have every Southern resident has been photographed this year at least once, and we have 2 new calves. So, and anyway.
Thank you, everyone, and thank you to the organisers for inviting us to speak. So I'm Darren Croft. I've been working with the Centre for well over 10 years, and really closely over the last 5 to 8 years. So I'm from the UK, as you can probably tell by my accent, from the University of Exeter, which is in the southwest of the UK, and I'll explain a little bit how I got involved with the Centre as we go through the slides. And as Michael said in the introduction, I'm going to tell you a little bit about the academic work. So Dave's done a really wonderful job, and Ken beforehand, of introducing Orca Survey, this year-on-year census of the population. And I'll tell you a little bit how we've been able to use that data to ask some really fundamental questions in science. This is going to be a little bit of an update. I don't know where Giles is now. Giles, Ken and I stood on this stage in 2016, and we talked a little bit about some of the work that we've been doing. So I'll just recap on some of that quickly and tell you about where our science has gone since then that we've been doing with the Centre. But science progresses by building on the work of others, and 2 individuals in particular that have been really monumental in the long-term studies of these populations are Mike Bigg and Ken Balcombe. And a lot of what we're going to be talking about today, a lot of what I'm going to be talking about today, is not just using the methods that have been developed, the data, the long-term data sets, the scientific discoveries. And we would only be where we are today, or we wouldn't be where we are today without those contributions. So I just want to acknowledge that. And then the many other people who've worked and collaborated on this project to make possible what I'm going to talk about today. So when I say we, I mean they. I rarely get to do the hard work, the analysing the data, analysing the photographs. I just want to highlight Emma Foster. Emma's over here. We've heard a little bit about Earthwatch and how influential Earthwatch was for the Centre. Emma came to the Centre for Whale Research. I'm going to look at Dave. What year do you think Emma came for? 2004 as an Earthwatch volunteer. I then encountered Emma at the University of Bangor in the UK in 2006. I'd just taken up my first lectureship, and Emma came into my office telling me about this wonderful organisation that she'd volunteered with and this incredible data set, and how she'd like to do her MSc dissertation with the Centre, and she talked me into it eventually. And the rest is history. We've been working together ever since. So Earthwatch also brought Ken and I and the Centre together as well through Emma. And then the many other people that have contributed and collaborated on the work. So you guys don't need an introduction here. The Centre Orca Survey went through its birthday for 40 years in 2016, and we've been able to track, or they've been able to track, those individuals. There's Ken and I in 2016. And that's me when Orca Survey started. Just to put into context that building on the work of others, there's an entire life of work. And I was about 8 months old when Ken set out on his first encounter with the Southern residents. So it's a real privilege to have been able to and continue to work with this long-term data set. One of the things that emerged quite early from this data, and those of you who are here, you'll have seen this slide, and I'm sure it's not going to come as a surprise to others, is the pattern of longevity between males and females. So you're going to see a few plots like this. So we have age of animals along the bottom. We have survival along this axis here. At the top, everyone's alive. At the bottom, no one's alive. Females in pink and males in blue. And females are reproductive. They have this period in their late 30s, early 40s when they have their last calf. But they have this really long period here where they're still alive, they're above this line, but they're no longer reproducing. So they have this post-reproductive lifespan. And as I'll go on in a couple of slides, that's really unusual. One of the other things that's unusual about this population, and we're still trying to understand fully, is why males and females have such different survival. But I'm not really going to focus on that today. We're going to focus on this post-reproductive lifespan that these females have. So Sam Ellis from Exeter. Sam came and did a postdoc with us in the Centre. And there was a lot of misunderstanding in the literature about how common menopause or this post-reproductive lifespan is in animal societies. So in captive animals, quite often animals will live beyond their reproductive years. But that's because they don't have predators. They're fed, they have medication. So they live beyond the age at which they'd live in natural populations. I promise I will get to killer whales. There's a lot of different species on here, but we have killer whales here. Green is the female lifespan that's reproductive. Yellow marks the point at which the female stops reproducing, and then how long they live as post-reproductive. These are humans, so this is us. These are the southern resident killer whales, and these are short-fin pilot whales. And we looked across many species. Menopause is really rare. There's only over 5,000 species of mammals, and this paper here, I can't remember if this was 17 or 2017 or 18, we were able to identify just 3. Sam wasn't satisfied with that, so he went off and he trawled the literature to look at corpora counts, so scars on the ovaries of toothed whales from dissections from strandings, and we can talk about more later. Using that data, he was able to establish what the reproductive history of individuals, females, were, and at what point they'd stopped reproducing, and how long they'd lived after that last point of reproduction. Sam actually identified that beluga, narwhal, and we already knew the short-fin pilot whale went through menopause. We don't have good ovary data on the killer whales, that's why they're not here. But Sam identified in this work, we have killer whales, short-fin pilot whales, narwhal, and beluga, all having evolved this post-reproductive life, and actually menopause evolving at least 3 times independently within the toothed whale. So it's a really fascinating group of animals to understand how this unusual life history has evolved. And I'll say it again, there's over 5,000 species of mammals, and it's just this little handful here, apart from humans, where females go through menopause. And so from an evolution perspective, that's a real struggle to understand, because we think of evolution progressing by individuals maximizing their reproduction, churning out as many offspring as they can. So why should a female stop early? How can that evolve? And that's something we've been working on for the last 10 or so years with the center. And there's 3 key hypotheses. So the mother hypothesis, that females need to be alive to support their last dependent offspring. That was the first hypothesis developed to explain the evolution of menopause. That was developed in the 90s to the grandmother hypothesis, so that there are grandmother benefits. Grandmothers being alive can increase the survival of their grand offspring. And I will talk more about this in a few moments. Reproductive conflict, the actual idea that there might be some conflict within the family group that might push females to be post-reproductive. So those 3 key hypotheses, using this amazing data that the center's collected, we've been able to test all 3 of these. So this is a slide I showed at Superpod in 2016, so I'll skim over it quite quickly. This is showing that mothers boost the survival of their males. So you'll see a few slides like this. This is time since birth, strange way to label the axis, just call it age along the bottom here. And then this is survival probability on the Y, on this vertical axis. At 1, everyone's alive. At 0, no one's alive. Females in red, males in black. And then this is just looking at the survival pattern of males and females, just generally in the population, to age 40. We can look at what happens if their mother dies. So if their mother dies and the offspring is age 15 in males, we see this line drop. So their survival is being reduced. So they have an increased risk of mortality. No effect in females. So we're seeing a strong signal here that mums are keeping their sons alive. We can, with modeling, we can extend that age to 35 and look at what happens. And now there's a really big drop in male survival. So mums are keeping their sons alive, and we'll go on perhaps to look at how they might be doing that later on in a few slides. So we talked about this in 2016. One of the ways we were able to show they were doing this is by sharing knowledge of where to find food. So Emma watched, I think, 500, 600 hours of video that Dave and team at the center had collected, scoring who was leading in front, and was able to show that these post-reproductive mums were out leading the group to find the fish, and especially during times of low salmon. So they have ecological knowledge of where to find food and when salmon's in short supply, they're out in the front, guiding the group around to find food. And we've heard in other talks, finding food is absolutely crucial. These whales are living on a knife edge. If they don't get enough food, they're not reproducing successfully, and their mortality is higher. So now we get to the new stuff. So that was a kind of recap of where we were in 2016. Now we get to the new science that's happened since then. we've been able to go on a look at grandmother benefits. So in human societies, the major benefit of menopause in hunter-gatherer societies is not on the sons and daughters, it's on the grand offspring. It's the grand offspring that the grandparents really are able to increase, in the scientific word, fitness, the transmission of their genes to the next generation, their genetic material, through their grand offspring. So we've been able to look at this using this amazing long-term data set on both the northern and the southern residents. We have age along the bottom, we have survival. So again, anything at the top, everyone's alive. Anything at the bottom, everyone's dead. And the different colors on this chart now represent different scenarios. So red is your grandmother is alive, and so everyone's doing quite well. Blue is your reproductive grandmother dies. These killer whales have overlapping generations, so you have multiple individuals or individuals from different generations breeding at the same time. So it's possible that your grandmother's having a calf at the same time. We'll come on to talk about why that's so interesting. And this is what happens if your post-reproductive grandmother dies. So if your grandmother dies who's no longer reproducing, remember, any movement of the line this way is an increased hazard of mortality. And so this is asking what happens if a 5-year-old whale loses their grandmother. Well, if their grandmother's post-reproductive, their risk of dying rockets, it increases. What's interesting is this isn't just if you're only 5, this extends to if they're 15 years old. So, you know, perhaps no longer dependent on that kind of babysitting care. And even all the way out to a 20-year-old individual that loses their grandmother, then their risk of mortality increases. So these post-reproductive females are helping not just keep their offspring alive, but their grand offspring alive within these family groups. Yeah, so the mortality hazard jumps by about 4.5 times larger when you've lost a grandmother. A real challenge, though, is why stop reproducing? So if we contrast killer whale societies to elephant societies, they're both matriarchal. They have a different social structure, which is important, and we'll come to that in a moment. But we know that these old matriarchs are really important in increasing the survival of their offspring and grand offspring. There are very similar effects in elephant societies. We also know that these matriarchs in elephant societies have ecological knowledge of where to find food, where to find water, and that's one of the ways they increase the survival of their offspring. Grandmother benefits actually happen in other species as well, where individuals continue to reproduce until the end of life. So these grandmother benefits alone can't explain why menopause, why this post-reproductive lifespan has evolved. Something has to hold back that reproductive period. Something has to be preventing the female from continuing to reproduce. Some of the theory in human societies have suggested that this is due to, for example, the risks associated with late-life childbirth. When you actually look at the data, however, those effects are really small and probably not large enough to actually explain giving up reproduction, the cost of giving up reproduction. And so there's likely something else going on. And this is where the reproductive conflict hypothesis comes in. This was developed by Mike Kahn and Rufus Johnson. Both their photographs are on that slide of acknowledgements. They developed this around 2008, 2009, and it's been applied originally to human societies, and we've been able to apply this to killer whale societies as well, with the southern residents and the northern residents. What's important to just focus in on here for a moment are the social dynamics within the population and the mating dynamics. So this is just kind of a cartoon illustrating two matrilines, and what we hope is happening is males are mating with females from outside of their matriline. They then stay with their mom's group, and the female in the matriline he's mated with rears the calf. So sons and daughters stay with their mums, daughters rear the calves within the family group. What that means is that actually, if a son reproduces, there's no cost to the local group of rearing the calf, because the calf is reared with the other group that he's mated with. There's another important fact that emerges from this, and that's how the relatedness to the group changes as we get older. So we can think of relatedness as how many genes I share with my family group. So if I'm surrounded by siblings, I will have high local relatedness. If I'm surrounded by cousins, I'll have low local relatedness. They're sharing less of my DNA through descent, so we have less in common. What's really interesting about these killer whale societies, so this is the average relatedness, so it's just looking at an individual social group and asking how related, so I'm an average 0.5 related to my mom and 0.5 related to my brother. On average, we share 50% of our DNA. It's just doing that calculation. It's saying, okay, so on average, how related is this individual to its family group? So female-female relatedness, the relatedness between females and other females stays more or less constant. The relatedness between females and males actually increases as she gets older. And the reason for that is females are born into a group without her father because the father was from a different group. But when she starts to reproduce, she recruits her male offspring into the group, so her sons stay with her. And that actually means that that pushes up her relatedness. So as she gets older, she's becoming more related to her family. And we've only been able to establish this because we've got such long data to be able to look at over time. These are plots looking at what we'd expect in theory, and I'm not going to go into these in a huge amount of detail, but we've got killer whales here showing the same thing. So this line here is the average relatedness. This is relatedness to males, average relatedness. This is what we'd expect to see in ancestral humans with the same patterns, with different patterns of dispersal and mating, but the same patterns of this, what we're calling kinship dynamics, so an increase in relatedness. And this is what we see in elephant societies and typical mammals. Actually, individuals get less related to their group as they get older. So something that we have in common with killer whale societies is we get more related to, females are getting more related to their family group as they get older. And that's different from typical mammal societies where females get less related to their group as they get older. And this is really important for this group of animals and our own history and our own evolutionary history as well, because how related we are to our family will determine from an evolution perspective, will determine how much we invest in helping or harming behavior. And so Rufus and team were able to run some models and actually predict how much females should invest in competitive effort depending on how old the females are. So here we have old females on this side, here we have young females on this side. It's saying, okay, so females are getting more related to their group as they get older. How should that change their investment in competitive effort, which is red? And how should that change their investment in reproductive output, which is blue? The key take-home message here is this is predicting females should compete more, try and reproduce. Older females, so once they start to become high related to their local group, should compete less. So compete might be how much food you try and eat versus share. High competition would be eating more food, sharing less. We know these post-reproductive females share more of their food, for example. And we'd expect them to show lower levels of fecundity. And so this sets up this kind of conflict between these generations, old and young females, where young females should compete more than these older females. We've been able to test this using this amazing data that the Centre and our colleagues at DFO have collected. Again, this is using the Northern resident data. So I mentioned earlier on that there are these events where grandmothers and daughters are trying to reproduce at the same time. So you have these overlapping generations reproducing. And so we can ask, well, what happens to the calf survival if this old generation mother has a calf and her daughter has a calf at the same time? How does that influence survival? Remember these graphs, we're looking at the same thing again. We have age along here. We have survivorship on this axis here. Anything up here is alive, anything down here is dead. This is the offspring of the older generation mother, so it's lower than this line. This is the offspring of this mother, so this calf here. This one is this calf here. This calf has higher survival than this calf, but only when those females are trying to breed at the same time. If they're breeding out of synchrony, then there's no difference in the survival. So this fits perfectly that prediction that these older generation mothers are, if you put it in practical terms, probably sharing more of the prey they're catching. These young generation mothers are consuming more of the prey they're catching. They're investing more in their family group. These guys are investing more in themselves and their immediate calf. And that's leading to a difference in survival between these two calves. So, and interestingly and importantly, just the same processes we think were going on in early human societies. They showed the same patterns of dispersal, different patterns of dispersal, but the same patterns of kinship dynamics. And there is evidence in some human societies that reproductive conflict is important in explaining why females stop reproduction before the end of life. I keep drawing on this example with elephant societies, and they share a huge degree of similarity with the killer whales, but also a really big difference. We saw those patterns of kinship dynamics. Males disperse from these family groups, which is why we don't see menopause in elephants, because mums don't have their sons around, and we saw those survivorship curves. The mums are investing in their male offspring. If you remember those graphs of survival, the sons had the higher mortality risk following the death of their mother. We know these post-reproductive females are more likely to share the fish they catch with their adult sons. I'm really excited to be able to tell you about some work that literally is just hot off the press in that it was published at 8 a.m. this morning. So you guys are the first people we've been able to talk about it with. So we've been really interested in thinking about, well, the big challenge for understanding the evolution of this unusual life history is to understand how females help. So we know they share food they catch. We know that they lead the group around the foraging ground, so they have this ecological knowledge. We know in these other long-lived societies that individuals also have social knowledge. They have knowledge that allows their group to navigate complex social relationships, to be able to resolve conflict or avoid conflict. And so we were interested in trying to tease that apart in the killer whales. And Charlie Grimes, Charlie was one of the pictures at the front. This project actually goes back to, I think, 2015. Dave and Lauren were talking in the office, and I think Dave might have said, maybe we could look at some rate marks. And so that's 8 years later. And a huge amount of scoring of photographs I'll show you in a minute. We've just had this work published this morning, led by Charlie, scoring these, what we're calling socially inflicted injuries. So we can see some rate marks on this male here, some rate marks here. We're not saying this is all due to aggression. Clearly, some of this is due to aggression. Some of it might be due to rough play. But where there are these scratches, it provides a route of infection into the animal, potentially resulting in quite significant costs if they get diseased. Like I say, released this morning. This was a quick screen grab from my computer. It's really nice to see this work being covered in the international press. This is how Charlie and team did this. So this is a photo analysis tool, and I highlight this just to show, when I say we, I don't mean we, I mean they, how much work goes into these studies. It's 8 years of data collection. Each photograph that they've looked at has been digitized. They've gone round the whale and highlighted how many pixels of that whale, how many pixels does that whale occupy in the image, and then how many pixels of that image are rate marks. And then from that actually calculates proportion of the whale that has this injury. And we can look at then those individual life histories and how those patterns of injury change through time. And they did this across 8,744 photographs. So you can imagine it's a huge amount of work, and I didn't do one of them. So it really is, it really is their work, not my work, across 148 individuals. So what we've been able to find, well, this is the second paper that's come out of this project. I don't have time to tell you about the other one. We can talk more about it later. Really, we're interested here in looking at how post-reproductive mothers have influence on their family group members. So what we're going to see in this graph here is rate density. So as rake density is higher, individuals have more rakes. We have 4 different scenarios I just want to talk through before we look at the data. No mother, so your mother's not in your family group, and there's no other post-reproductive female present. So you don't have your mother, and there's no other post-reproductive female around. This is that you have your reproductive mother present in your family group. This is if your mother is post-reproductive, and she's with you in your social group. And this is if there is an other post-reproductive female present. So we have these 4 different scenarios for males and for females. So if we look at males to start with, we find that this differs from these other 3 scenarios, whereby sons or males that have their post-reproductive mother experience a lower rate of these socially inflicted injuries. That doesn't matter. You don't get the same benefit if your mother's reproductive. And what's really interesting is you don't get the same benefit if you're just hanging out with another post-reproductive female. So it's not that this post-reproductive female is just kind of policing the social group and saying, come on, boys, call it a day, no more fighting. It's their mum that's leading to those benefits. When we look at females, we find no effect. So females overall have a lower incidence of these socially inflicted injuries, as we'd expect, but there's no influence of the post-reproductive female, or no difference, rather, between these different social scenarios on the level of rate marking. Charlie has been able to go on and look at, well, are there any grandmother benefits happening here? Are the grandmothers benefiting their grand offspring? And the answer is no. So there's no difference between these different social scenarios of having a post-reproductive grandmother or a reproductive grandmother in males and females. So yet another example of how moms are providing benefits to their male offspring. And the reason that they're directing their support to their sons is because those sons have higher reproductive potential. We know that a small number of males in the population will sire most of the offspring. So from an evolution perspective, from a genetic perspective, moms investing in their sons, that pays more. There's the potential to have more grandchildren through your son than through a daughter. So, not sure what's going on with the text there, but this social role, again, I draw the similarities with human societies. In human societies, we know that the elder women in hunter-gatherer societies, for example, can play a really crucial role in negotiating through social conflicts. And just as in the killer whale societies, we need to understand what context individuals are getting these rate marks, but there's strong evidence here that it's these older females that are somehow helping their group to negotiate these challenging social contexts. And just want to finish on another project that we've been running over the last 4 years, 3.5, 4 years, looking at the Biggs killer whales. So everything we've talked about so far is focused on this amazing long-term data set on the southern residents and the northern residents. But over that same time period, the same people have been documenting the Biggs, or formerly the Ts, the transient killer whales. And so Mia has been doing a PhD with Michael, the centre, and I, looking at, okay, so what about other ecotypes? We've talked a lot about menopause and killer whales and survival benefits, but we've got a really exciting opportunity here to look at another ecotype with a different social structure. I don't have time to talk about this now, but Mia had a really great paper come out last month, sort of giving an update on the Biggs social structure. But Mia, has been able to look at whether or not they also go through menopause. So this is the last slide with data before I hand over to Michael. I'm just going to talk you through here, these slides. So here is let's call this reproductive output here. So no reproductive output, high reproductive output, and here is age. So that's the first graph to understand. So we can see here, no births, no calves, mid-teens, start to reproduce, have calves, stop, still alive, but no calves. This is southern residents. This is a survival plot, so this is the sort of thing you've seen before, whereby everyone's alive, everyone's dead, females in red, males in blue, and the red line is above the blue line. everyone's stopping reproduction about 40, 40s here, females are continuing to live well beyond their last point of reproduction. So that should be very familiar. We've looked at similar slides before. I just wanted to talk through it because we're going to see the BIGS data in a second. This is the northern residence, so looks very similar. There's more data, so it's smoother, but we see the same pattern of survival, females living longer than males, and having this incredible post-reproductive lifespan. What was really surprising for us is when we looked at the BIGS, we find exactly the same pattern. That start reproduction, have calves, have calves, have calves, stop having calves, but continue to live for a significant period. This is the point at last reproduction, somewhere around here. And you can see this line is above 0 all the way out to here. So these also have this incredible post-reproductive lifespan, despite having a different social structure. And so I'm not going to say too much more about that at this point in the interest of time, other than to say we've got another really exciting journey to go on that's going to take us another decade or something to work out what's going on here. And that's the exciting thing about science, that you try and solve one question and you end up with loads more. So just to conclude then, before I hand over to Michael, I think just want to highlight again, menopause is this really unusual trait. We heard John Ford in the video last night just say how special these whales are and how unusual they are, and they really are. It's just incredible that they have this unusual life history, unusual social behavior that's so similar to us. We've shown that both mothers and grandmothers provide benefits. We've shown, but these benefits can't explain why these females, they can explain why the females live such a long time, but they can't explain why they stop reproduction. There's some conflict in the family. So it's a story of cooperation, of helping, but also a bit of tug of war in the family about who's going to get to reproduce. And these older females get pushed out of the breeding spot by the younger females. And this latest work that Charlie's just had published today shows that post-reproductive females provide this important social role. And we've got some really exciting new work to come on BIGS, which I think Michael is going to tell us a little bit about now.
Thank you. Thanks, both of you. That was really great. As Darren said, I'm going to talk a little bit about some new work we've been doing, really focusing on kind of this newer side of Center for Whale Research field work, which is actually using unoccupied aerial systems or drones to study killer whale behavior from the air in a lot more detail. As Darren kind of pointed out, through this demographic data, we've discovered all of these really interesting effects of the social environment on survival and on reproduction. But it's hard to say the exact mechanisms that are going on if we're not observing individuals' actual behavior. So I'm going to talk about some new work. Before I get started, you will see this symbol occasionally. This means please do not tweet this, Facebook this, Instagram it, TikTok it, whatever, because a lot of these results are unpublished and preliminary. I'd really like to share them with you, but yeah, we don't want them out in the roaming free in the world just yet. So we fly a little Phantom 4 from our research boat, Orsinus. That's me piloting the drone to be caught in the Strait of Georgia while we were working some teas. And you end up with this really gorgeous footage of groups of whales, doing all kinds of things, socially interacting, moving around in their match lines. This is actually JPod from just earlier this month, just north of Limekiln. And you get to see so many interesting things that are really hard to observe from the boat directly. For instance, you can see some really interesting social interactions. So this is the L12s, part of the L12 group, the L94s. Again, just off the west side of San Juan Island. That is our new kid, L127, being pushed around by mom there. This kind of tactile social interaction is really common between moms and calves, but it's also really common just generally in the southern residents. And the calves are definitely the center of attention. So she's getting supported there, and you'll actually see her sister come in just a second. Yeah, hold on. It's worth the wait. While we were on the boat, Dave said, "That's no way to treat a calf." But they're fine. It's part of their normal kind of social development, it seems like. But we can actually watch these videos, and myself and some master students and interns go through and score every single time a pair of whales comes into physical contact in these videos. And that lets us build social networks. And somehow we actually haven't had one of these diagrams yet in the talk, but so each one of these nodes is a member of JPOD in 2019. These edges represent physical contact between individuals. Square ones are males, circles are females, and they're sized according to age. And the thicker lines mean they came into contact more often. What we were able to find with this is that there are patterns in their social relationships that we can get by looking at actual physical contacts that you can't see by just looking at who's spending time together, who's in the same group, kind of these classic association measures of animal social structure, especially relating to age and sex. So what we found is that while matrilineal kinship, who are you related to, who's your mom, who are your brothers and sisters, is really important in structuring these relationships. These are colored by matriline, and you can see they kind of group together. There were also really important patterns around individuals being in contact with individuals of the same sex. There's a lot of what we call homophily, so males tend to play around with males and females tend to play around with females, and individuals of the same age, so young individuals interacting with other young individuals. And as I was saying, the young individuals are the ones who are really central in this network. Both males and females get less central in these social networks as they get older. What this really showed us when we did this analysis back in 2021 and published it is that there are things about killer whale social structure that we still don't have a great handle on, and that the drone is a really nice way to get at them. One area of behavior that we're really interested to look more deeply into is cooperative foraging and prey sharing. So this is a young whale here, and there's actually a salmon right there that she's going to be chasing. This is J53. And this is from last year. And we kind of knew that these whales would work, we'd see multiple whales foraging. We think they were searching for food together. But what we hadn't really seen is that they seem to actually work together to catch individual fish. What you'll often see is a young whale like J53 keeping the fish at the surface, and then an older female will come in kind of out of nowhere and actually catch the fish. And you'll actually see her shake her head and break the fish in half and share half of that fish with J53. What's really amazing about this video to me is not just the way that they work together and the fact that they shared. It's the fact that J40 and J53 are not closely related. They're both in JPOD, but they're not cousins. They're not, they're not sisters. We're also interested to see how whales might benefit from other less obvious benefits of the social world. So a lot of what you see resident killer whales doing is just this, traveling in formation, where you have usually an older female like J19 in the front, and then maybe a couple matrilines. So this is the rest of the J19s, here's the J22s. And we're really interested to look at not just the benefits of following an old female, but maybe the energetic benefits of following anyone. Can you fall into the whale's slipstream and actually kind of coast and get an energetic benefit from swimming in a group? We're not just interested in the residents, though. We also do collect data on Biggs killer whales from the drone. This is the T100s in Griffin Bay. Just like the residents, these guys share food. Of course, their food is seals. There's no blood in this video, but there is a seal. And what we'll actually see is someone will catch a seal, and you'll see this whale has a seal here, and they'll actually pass it among the entire matriline before they even start processing it properly. So you'll see this whale is going to pass it to older brother. Older brother is then going to basically immediately pass it to his mom. And then she's going to pass it almost immediately to the youngest whale in the group. They just pass it down the line. And they haven't even started eating it yet. it's almost, this isn't particularly scientific, but it has the feeling of ritual to me, passing something around. But so our current big questions that we're still kind of interested in going forward with is, how do social relationships respond to environmental and demographic change? So that could be changing abundance of their primary prey, which is Chinook, the birth of new individuals into the group. As we saw, the young individuals are the ones who are really central in these social groups. How does that change when a new baby is in town? And how does they respond to the death of key individuals as well? If you lose that old post-reproductive female who leads the group, how do the social relationships change? Why do residents hunt together, and what predicts who they share with? So I showed that video of animals kind of working together. We're really interested to get into the nitty-gritty of the data and see what are the benefits of working together as a group. Do you have to put in less effort for your hunt? Does the hunt take less time? Does it just help build social relationships? What is the benefit of hunting together? And on the same kind of note, since they're not just sharing within their matriline, what is predicting who they're actually sharing with? How do BIGs and resident within unit social networks differ? So we've also started quantifying social contacts within the BIGs killer whales, and we're interested to look at how those networks are similar or different from the resident contact networks. And then the big one for me, this is kind of the ball game, is can we predict survival and reproduction from behavior? So can we look at how much prey you've shared or received to predict whether or not you survive or have a kid successfully? Can we predict whether you'll survive based on your social centrality or the cohesion of your social group? And can we actually quantify energy expenditure to look at survival and reproduction? And to kind of dig into why we're so interested in that, there are really three things here that I'm interested in understanding the relationships between. So salmon abundance, you could also put in anything about their environment here, but salmon abundance is the really crucial one. The social relationships between individuals, and then ultimately survival and reproduction. We know that salmon abundance affects survival and reproduction. It's their primary prey. This makes sense. But we also know that salmon abundance is affecting social relationships. When you look at the cohesion of these association networks between individuals, there's a positive correlation between the abundance of their primary prey and more cohesive social networks. Basically, if you're hungry, you're not going to get together and party. And as Darren was laying out, we also know that social relationships are then affecting survival and reproduction, both relationships with your mother and relationships with your grandmother, but also social relationships more broadly. Males that are more socially central in their units tend to survive better, especially in years of low salmon abundance. But there are also costs to the social environment. One of the results that we published this year that we haven't had a chance to talk about yet is while mothers are providing these survival benefits to their sons, they're also taking on a huge reproductive cost. So each son that a female has reduces her expected reproductive output in a year by about 70%. So this is a 21-year-old female who has no offspring, has about a 1 in 5 chance of reproducing in a given year. That same female, if she has a single male offspring, that's reduced to less than 1 in 10. So there are costs and benefits to the social environment. And we also suspect that there are relationships between the turnover of individuals from survival and reproduction and the relationships that individuals have. So this is a huge interrelated system. And if we want to predict where this is going, which is our main goal, we kind of have to understand all of these bits and incorporate them all into our models going forward. Now is when I pitch to you how we're going to do this. As I think a lot of you know, the southern residents have not been in our study area as much in recent years as they were in the past. As some of you may also know, we currently work out of a 1981 Boston whaler. In order to kind of work more safely, in a larger range, and more efficiently, and increase our data collection, we're looking to upgrade our research vessel, which is kind of our most crucial tool. This is a diagram we got sent a couple days ago from the folks making this vessel down at Life Proof Boats in Bremerton. And this is kind of a rough estimate of, this is our current kind of study area based out of San Juan Island. This is where we reckon we can get to in this new vessel. We are fundraising for this vessel.
If you want to support us, this would be a huge help to our research to support this vessel, whaleresearch.com/support-CWR. They have started building the boat, which is very exciting. It's taken quite a while, but it's going to be an aluminum hull boat with a foam collar that'll keep us nice and safe and stable, be a lot better for drone work and photo ID work. So yeah, just to kind of bring it back around to the summary, we've got our 3 pillars. This is what we've been talking about today: the research that we do, orca survey and aerial observation. Conservation, that research is feeding into evidence-based decision-making, understanding what risks the southern residents face, how severe they are, and what we can do to help. And education, sharing that information with the public, both through events like this, through our website, through the outreach center in town, which again, I highly recommend you all go to if you haven't been yet. Yeah, and thank you very much. This has been great. Appreciate you all listening. And I'm not sure if we have time for questions. Yeah, if you guys want to come up and, yeah, so any questions for any of the 3 of us? Yes? Sure. There's 2 people in the line. Either go first.
Hey, Michael, do you have a GoFundMe? Because that might work.
I don't believe we have a GoFundMe for the vessel at the moment. We do have a fundraising page specific for the vessel set up on the website through PayPal, but I don't think we have a GoFundMe page at the moment.
Okay, how about social media to get to your website? On the meme for the boats.
Yeah, so I believe we posted about it on our Facebook and Instagram, and
We're just starting that campaign and
yeah.
sharing it. So you guys are some of the first people we've talked to at this sort of stage about what we're doing and why it's important. But yeah, we will be ramping that up. Thank you for the suggestion as well.
Yes.
Dave talked about having seen everybody. You didn't and that the babies look great this year and last. You didn't comment about the health of everybody else. And I read recently that the voting regulation was reimposed because there were at least 10 individuals who are looking like they're not thriving. Could any of you comment on how everybody's doing?
I'll maybe we'll tag team this. I'll let Dave comment on how they look to us, I suppose, and I can explain quickly, to my understanding, the report you're talking about with the 10 individuals. That's based on SR3's photogrammetry work, where they have a drone measuring the morphometrics of the whales and measuring their shape. And they break those measurements, they correct them for age and sex, and they break them down into kind of the bottom, I think it's the bottom 25% of whales are considered low body condition. So if you're in that bottom quartile of whales, you're in the low body condition. So it's a designation of whales that are vulnerable, because some of their analysis has suggested whales in that class are more likely to die. However, they're still, the survival rates still mean that whales in those classes are most likely going to survive the year, but they are more likely, they're at greater risk than other whales in the population. So it's definitely an indication that those whales are potentially vulnerable. But it's not necessarily these whales are immediately on their way out kind of thing. Do you have anything to add?
I don't know. Yeah, I'll just say that, looking from the boat gives you a little bit different angle, and you can't see everything that you can see from the air. However, we got a good idea of what most of these whales ought to be looking like. I mean, it's amazing when you look at all the individuals and you can see the differences in body shapes of these whales. Not just like people, not every whale has the same body shape. And there are some whales that, are always kind of fat behind the blowhole, and there's other whales that have a little dip behind the blowhole, but it's not a peanut head yet. That's just the way those whales look. And so you always kind of have to, we wait quite a bit before we start saying we're worried about a whale from the boat level. And, last summer, 2022, we did have some whales that were noticeably looking thin. J27 was looking pretty grim in June. And then when K-Pod finally showed up, new mom K20 and her son K38 did not look very well at all. They were obviously emaciated, not quite full on peanut head yet, but they were definitely kind of worrisome. But as the summer went on, they filled back out, and they're still here. And J27 no longer from our angle looks, like he's in trouble. For the nitty gritty details, we'll let SR3 say things. But the only whale this year that looked like, after a fairly good spring, J56 has been a whale that's been perpetually, in danger, even though she's the happiest little endangered whale I've ever seen. She's constantly bouncing around and socializing with other whales. She did show up in late June looking like she might have taken a step back. She was peely, a little on the thin side. I'm not so sure that in the coming weeks she might have gained a little bit of it back. But, every single one of these whales is kind of, at risk. They can all drop out at any moment. So it's constantly, that whale might be a little thin, but that doesn't mean it's not going to survive. And you can have whales that look perfectly healthy to you, and then they don't show up. So I'm not sure what it all means, but we just keep watching. And we'll let you know when we know. Yeah.
Just go behind you there. I think you're first.
There have been some reports that there have been some skin lesions on the southern residents. I'm wondering if you noticed them, how serious they are, where they came from, how it affects the health.
So the question was about skin lesions on the southern residents and where they came from and what they might be doing and what they might be doing to their health, and if we've noticed them. As Dave was saying, whales show up peely. They show up with all kinds of discolorations and marks on them. There was a paper recently that used CWR photos that we collaborated with to kind of analyze the occurrence of a lot of these different lesions and discolorations. The answer to the question really is we don't know what they are. We don't know where these lesions come from. And as far as the analysis stands right now, there doesn't seem to be any correlation to deaths or reduced reproduction. That being said, this analysis that's been published is a really kind of initial survey. It's literally the first time that we and our collaborators have really tried to quantify the occurrence of these skin lesions in the whales. It'll take a lot more research to kind of narrow down what the cause of these different lesions are. A lot of the lesions are, the lesions we're talking about vary widely, and they probably don't have all have the same causes, and they might all have different health implications. So as far as we know right now, there's no obvious health implications of these lesions that have been identified, but it's an area of more research.
These aren't like the Maury Firth dolphin lesions. These aren't open wound type lesions that they're talking about.
May I ask, is that to expand on Diane, is this specific to the southern residents, or is it affecting any other populations?
It's a really good question. Is this specific to the southern residents? And the answer is we don't really know. Lesions, to my knowledge, haven't been quantified in the same way in other populations of killer whales. So I think that's one of the areas for future research, is to see how the occurrence of these lesions in the southern residents compares to the bigs and the northern residents and whales in other parts of the world.
So we had a question here at the front, and there's somewhere in the middle. We'll go here first.
Yeah, what sort of hopes and dreams and ideas do you have for understanding where these whales are when they're not here?
Ooh. Do you want to chat about that?
Oh, well.
Yeah, you go. You go for it. You're the one who was out west.
Hopefully, if we get a boat that's actually safe and working out there, we will get to spend more time out there. We just had them 2 days in a row, 14 miles off the south entrance of Strait of Juan de Fuca, and they looked really happy out there. They were feeding, they were socializing, they were, doing everything. If they're not going to come in, it is certainly an area we would like to work more. And if only, not only for the southern residents, but for just everything you can get out there off the entrance to the strait. You can get northern residents out there. You can get all our transients are bigs. I mean, and you can get some exciting kind of semi-exotic, coastal bigs out there too. Not to mention offshores, are always a possibility. So it's a great place to work. It's just, big water, and logistics of it all is expensive, and you're at the mercy of the weather report. But they're out there. I don't think they're wandering around looking for the single fish in the ocean. I think they're out there where they know they are, and they're pretty much planted out there in that area off the at least I think during the summertime off the mouth and up toward Bamfield, that whole stretch. So if we can figure out a way to work easily out there, we probably will. And hopes and dreams, who knows? We're dreaming of, who knows? Maybe we could go up to Ketchikan and work with northern residents or something like that. But
There was a question
Canada.
somewhere here in the middle. We'll go with you because I think you had your hand up first.
I'm curious, aside from the drones, and I saw the photo imaging, what technology are you using and what's on the horizon that you'd like to use? With the data collection.
Yeah, I mean, us personally right now, we're really focused on classic photo identification and the drone data collection. In terms of data processing, there's potentially some exciting things on the horizon. We're really hoping to start using some machine vision stuff to actually potentially help identify whales, but we're pretty good at that. But it might help actually track whales in the video to get really fine scale measures of how they're moving through space, how they're chasing fish. So the data collection, I think we're pretty solid on for now. Obviously new stuff happens all the time. But the data processing potential for kind of machine learning and AI stuff is an area we're definitely interested in looking at.
I think we'll go here.
Yeah, I'll let you figure out who's.
Keep an eye. I think you were next. Yes.
So these southern residents particularly, as you guys are all saying, are really on a knife's edge. They're losing a lot of pregnancies, their social relationships are disrupted, all of these sorts of things. And so then when we put these sort of graphs up there about who shares with whom and their social networks and things like that, I feel like that frame sort of assumes that that's normal. So I wonder how you all think about, the sort of the normalness of these relationships that we're describing. Of course, we know that human social societies and social relationships work very different under duress than they do in stable conditions. And so, how do you think about that as researchers?
Yeah, I mean, I'll let you guys say stuff as well. I personally think of it as when we study the southern residents, we are studying the southern residents that we have in front of us. And I think comparisons to the other ecotypes and the other populations, so comparisons with the northern residents and comparisons with the Biggs killer whales can be really informative for the ways in which pressure on these killer whales is producing these things. You're absolutely right. Nothing about social structure or social relationships exists in a vacuum. That's, we see it across mammals. It's one of the first things that tends to respond to environmental and demographic change is the social structure. So I think, studying that in the residents is something that we're actually interested in as a focus of our research, is how changes in the demographics and in the resources they have available are actually resulting in demographic change and social change. You could potentially project that backwards and say, what if they had a better social, what if there were fewer turnover events? What if they had more food? What might the social structure look like? I also think that comparison to the northern residents is really crucial as well.
So it's a really great question, and I think we can think about it at different levels. So for example, the fundamental basis of the social units doesn't respond to variation in changing the environment. There's no plastic dispersal, there's no budding of groups. There is in the northerns, but if you think about the southerns, there isn't. They stay in that family unit. But in other work, we've shown that how those units interact is entirely dependent on how much resources there are. So I think there are aspects of their sociality which are somewhat fixed and ancestral, because that that explains why they have this unusual life history. And then there are others that are more plastic. As Mike said, I think it's a really exciting. And that, I guess one of the strengths, one of the opportunities there is with this long-term data is there is such excellent data on their prey, which is also at risk. So it's one of the few, and they have a really simple, it's a really simple ecology, because 90% of their prey is one species of fish. During the summer, we've got really great data on that. So it's one of the few long-lived social mammals where we can actually start to ask some of those questions and hope to be able to get answers, because the data's there. We know enough about their ecology, and their ecology is well enough documented to be able to quantify it. Yeah, it's a really good question. I've not been keeping track of other hands. I'm also conscious of time. I think we've still got a couple of minutes, guys? Couple of minutes. So let's take 3 more questions. I think you very energetically hat on. Hand up. Yeah.
So, this is amazing. As you look through all these social relationships, I love this research, by the way. It's just wonderful about the kind of our guess at their social roles of all these orcas. Do you notice any non-stereotypic gender expression? I know at some point Spock was assumed to be male and looked like a male and then had a baby, and surprised us all. That just like other species, it's a bimodal distribution of kind of heterosexual relationships, but there's also diversity among sexual expression. And do you notice any non-heterosexual relationships among the orca populations, things like that?
Most of the sexual behavior we see in killer whales is between individuals of the same sex, especially males, young males, constantly. It's part of how they socialize. They do a lot of sociosexual behavior. So if you see high energy socialization and males are in there, you'll see sea snakes. In terms of gender expression, it's an interesting question, because I think that, it's hard to kind of really transpose human society concepts of gender onto. Yeah. There's definitely variation in reproductive activity and in social relationships and in social role, and as you were pointing out, physical attributes as well. You have females that for a lot of their life look like sprouters, and you have males that refuse to sprout, when you think they should. So there's definitely a lot of variation. I think we're going to need a lot more social interaction data to really get at, how much between versus within sex variation there is.
I have one other question related to the AI thing, because I asked you last night about the language and the idea that you might study that with AI. Is there any way to sync your video with audio so we can catch both at the same time and work on making sense of their language?
It's a great suggestion, and we have a grant under review to do something similar to that. It's not funded yet. Don't clap yet, please. But we're interested in looking at combining the audio and the video. It's definitely something we're interested in. Yeah.
I think. Yeah, in front of you there. Yeah.
I just wanted to ask really quick, specifically about you showed the data on if a new grandmother whale has a baby at the same time as her daughter, then her children have greater risks. I was wondering what that sort of time span of what is concurrent.
Yeah, so it's a really good question. So it was born 1 year either side of the other calf. So it's females that are gestating and lactating at the same time. Yeah, sorry, I didn't have time to go into the details. It's a really good question. We'll take one last question, or are we done? Okay, there's one up there.
Oh, there's one.
Yeah, so back to some of your slides. Near that end, you showed some different charts showing the lifespan of the southern, northern end of the fin.
Yeah.
And it showed that the males were tending to live a little bit longer beyond that post-reproductive age.
The males or the females?
It looked like males.
Oh, so yeah, it's a really good point actually. So just like human societies, males can continue to reproduce well beyond the time that females stop. So old males in the population are siring calves. So wait, I'll try and be quick. It's a real puzzle if you think about the southern residents, why males have such a short lifespan, because in comparison to females, because their reproductive success actually from the data increases as they get older, which actually means from an evolution perspective, old males have higher reproductive success, so evolution should be favoring them to get old, putting structures and mechanics in their body that keeps them alive for a long time, and that's not happening. So yes, males can live beyond the reproductive years of females, but they live shorter lives than females, but they continue to reproduce way beyond the point at which females stop. Does that answer your question? Yeah. Okay, in the interest of time, I think we'll have to draw a close, but thank you very much, everyone.